This is your Learn recording for lesson wave types, topic wave interference. By watching this video, a student will be able to successfully meet the following learning objectives. I can explain wave interference. I can determine the new wave from wave interference. The learning target for wave interference is the second half of the wave types lesson. And that learning target is I can explain wave interference. In that target includes the determination of the resultant wave, or the new wave's amplitude and wave height. So what is wave interference? Well, this is all about what happens when two waves meet. Two waves on a lake, on a pond, two ripples on a pond, two vibrations. What happens when two waves meet? When two waves meet, they combine to increase, decrease, or cancel each other out temporarily. This is called wave interference or superposition. We will use the term wave interference, but it is also called superposition. More than one wave or vibration can exist in the same space, and those waves can have different properties, different amplitudes, different wavelengths. If you drop two pebbles into the pond at different spots, what happens when those two waves meet? Those two waves will meet and overlap and combine. What will the new wave be like when they combine? When those waves meet, they combine, and the new resultant wave is either increased, decreased, or canceled out. And we see an animation here where the black line or wave is the new resultant wave, and the blue and green are the two waves that combine to produce the black resultant wave. So when the blue and green perfectly overlap, the two crests will combine to create a larger and bigger wave. But when the blue and green waves are opposite, a crest and a trough overlapping, they'll cancel each other out and neutralize each other. When they meet and combine and produce a new wave, this effect is called interference. This effect is called interference. There are two types of interference: constructive interference and destructive interference. And a way for us to learn this and remember this is to think back to when you were young, when you were a child and you played with blocks. There are two main types of block builders or block thinkers or players, so to speak. You are either a constructive block builder or a destructive block builder. Did you find it more fun to build a skyscraper, a building? Did you like to construct a building? Did you like to design and create something with multiple levels and floors? Or did you want to wait for someone to build a building and then destroy it? Which did you prefer to do? Did you like to destroy the structure or did you like to build the structure? Constructive is building it bigger. Destructive is destroying it, tearing apart, and making it smaller. Those are ways that you can think back to playtime and types of block builders that will help you with wave interference. Okay, so what happens when two waves meet? One thing that can happen is something called constructive interference. So think about a constructive block builder. They make a bigger building. If the crests of two waves meet, they can add together. So if you have two crests, two hills, they combine and add together and make a bigger mountain. Two crests adding together, when they combine and overlap, they produce a new wave, and that resultant wave is going to have an amplitude that's greater than either of the starting waves. So constructive interference makes a new wave that's even bigger than the starting waves. Constructive interference is when two crests overlap and they add together. Their amplitudes add together to make a wave that's bigger, and the amplitude is greater than either of the starting amplitudes, either of the original amplitudes. So here we have constructive interference. So for example, this is a crest. Remember, a crest is the high point of a wave. Crest is the high point of a wave. It's also called a peak, like peak of the mountain. So if you have crests of one wave overlapping the crest of another wave, when that happens and they meet, they overlap and they combine, they're going to produce a new wave. And that new wave is going to have an amplitude that is even greater than amplitude of wave 1 and 2. So the new wave, the combination of wave 1 and 2, the new wave is going to have a wave that's even bigger than wave 1 or 2. And an amplitude that's greater than wave 1 or 2. So if crests overlap, constructive interference occurs, and the new resultant wave is a wave of increased amplitude, and this means it is a bigger wave. So constructive interference is like a hill plus a hill making a mountain. All right, that's constructive. It's building something bigger, building something bigger. Okay, so let's try constructive interference with specific amplitude values. Two waves meet and the crest of one wave overlaps the crest of another. So you have to have two crests overlapping or two troughs overlapping. That's what we need for constructive interference. And when you have constructive interference, you add them together. So what do we have? It says wave A and wave B meet and their crests overlap. Yep, that's what we have here, the crests overlap. The amplitude of wave A is 5 meters. And the amplitude of wave B is 5 meters. What is the amplitude of the new wave? Well, we add them together. That's how constructive interference works. So 5 plus 5 is 10 meters. The amplitude of the new wave is 10 meters. That's how constructive interference works. The amplitude of the new wave is 10 meters. All right, very good. Let's continue. Okay, now there's another type of interference. What happens when two waves meet? Well, we could have destructive interference. And destructive interference is when the crest of one wave and the trough of another wave meet. So we don't have two crests, we don't have two troughs, they're not the same part of the wave overlapping. It's the opposite parts of the waves overlapping. Okay, so we have a crest and a trough overlapping. When we have opposite parts of the waves overlapping, what happens? Well, they subtract from each other. They subtract from each other. Okay, they meet and combine and subtract from each other. The new amplitude of the resulting wave is going to be less than either wave's original amplitude. Okay, so now it's like a hill plus a hole, and you combine a hill and a hole, and you get something much smaller. Okay, so we'll have to see how that works. It's not the best analogy, but it's a way to help explain what happens. Let's take a look and see how that works. You'll see what I mean when we look at an example. Okay, so two waves meet and the crest of one wave overlaps the trough of another. So let's see, do we have that here? Okay, so we have the crest of one wave and it overlaps the trough of another wave. Well, that's what we have here. That's what we have here. Okay, so we have the crest of one wave and we have the trough of another wave. So this is like the hill and this is like the hole. And when we combine them, what is our new wave like? What's our new wave? Well, we can determine what our new wave's amplitude is and what it's like by thinking what happens. Well, destructive. Remember we said destructive is destroying, it's tearing apart, it's taking things apart and making the building smaller. And that's what happens in destructive interference. It's going to make the amplitude of the wave smaller. It's going to make the whole wave smaller overall. And we can see that in this visual. When we add a hill and a hole together, some of that hill is going to disappear into the hole. So we're going to be left with a very small mound of dirt, so to speak. The wave is going to be very much reduced. So when two waves meet and the crest of one wave overlaps the trough of another, the result is a new wave with a decreased amplitude, and this means it's a smaller wave. Okay, so destructive interference, the new wave is small and the amplitude is decreased. And how do we determine the value of the amplitude? Well, remember we said we're going to subtract, so let's take a look at how that works. Let's look at this example. Is this destructive? Well, remember the crest and the trough have to overlap. Here we have the crest. The crest is the high point. Remember the trough is the low point. So the crest and the trough overlap. So yes, this is destructive. Okay, so this is the crest. Crest and the trough overlap. Crest is the high point, the trough is the low point. So we have destructive here. And our example says, our question says, wave A and wave B meet and their crest and trough exactly overlap. It says the amplitude of wave A is 6 meters. And it says the amplitude of wave B is 6 meters as well. What is the amplitude of the new wave? Well, remember, if it's destructive, we subtract. If it's destructive, we subtract. So 6 meters minus 6 meters, what do we get for our amplitude of the new wave? Well, 6 minus 6 is 0 meters. So our answer is B, 0. And so the new wave is actually a flat line. If they have the same amplitude and it's destructive, they cancel each other out. They cancel each other out. So that's a neat instance of destructive interference. So in destructive, it has to be a crest and trough overlapping. If they have the same amplitude values, they'll completely cancel each other out. So that's pretty cool. All right, all right, all right. Let's just do a check and make sure we're good to go with another example. Remember, if it's destructive, we subtract, but if it's destructive, the crest and trough overlap. So just double check. Here's the crest. Here's the trough. Trough is a low point, the bottom of the hole. The crest is the top of the mountain or the hill. So they overlap, the crest and trough, so this is destructive. And if it's destructive, we subtract. Okay, so let's try this. A crest of a wave with an amplitude 5 intersects with the trough of another wave with an amplitude 3. What's the amplitude of the new wave? Well, again, pause the video, try it yourself, and see what you get. We're going to subtract 5 meters and 3 meters, and we get the new wave has an amplitude of 2 meters. So the new wave has an amplitude of 2 meters, which is less than either of our starting waves. And that's what happens in destructive. It gets smaller. Destroy the building. When you destroy the building, it is torn apart and it becomes smaller. So the amplitude of the new wave is 2. The amplitude of the new wave is 2. You got it. That's right. That's right. So what type of wave interference is this? Just to twist a question around and try it another way and make sure we know our vocabulary terms. Well, see what you have lined up. See what you have. Is that 2 crests, 2 troughs, or a crest and a trough? Well, that's a high point and a high point, so that's 2 crests. What's two crests overlapping? What kind of interference is that? What is two crests overlapping? What kind of interference is that? That is constructive interference. That's constructive interference. All right, that's it. We have explained wave interference. We have explained the two types of wave interference, constructive and destructive, and we have learned how to determine the amplitude of the new resulting wave. You got it. We have accomplished our learning goals of wave interference and this recording. Great job.